Lesson 3.6, proving theorems about perpendicular lines, and eventually we're going to find the distance between a point and line. So we have two theorems. First theorem is if two lines intersect to form a linear pair of congruent angles, and the lines are perpendicular. So looking at this, if I have two lines and angles 1 and 2 are congruent, then the two lines must be perpendicular. The next theorem is that if we have two lines are perpendicular, they intersect to form four right angles. So what I like to do when I do have one right angle shown is I like to make all four of them. So let's draw conclusions. In first example, we have AB is perpendicular to BC. Okay, so what can we conclude? Well, first off, angles 1 and angle 2 are right angles. And that's perpendicular lines form four right angles. Okay, and our other theorem, if we have two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So what that's saying is I have two acute angles, they're adjacent, so they share a side, and their non-common sides are perpendicular. So then the two angles are complementary. Okay, we're going to do the proof for if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So we're given first that ED and EF are perpendicular, the two rays, and we're trying to prove that 7 and 8 are complementary. So filling in the proof, first statement is given. Angle DEF is a right angle. Well, that's perpendicular lines. For right angles. We go from right angle saying that the measure is 90 degrees, so that's definition of right angle. Measure of angle 7 plus measure of angle 8 equals the measure of DEF. That's angle addition. We're substituting in the 90 degrees for the measure of DEF. And then the definition of complementary allows us to say now that those two angles are complementary. Okay, you just have one to try, so pause the video and go ahead and try it and then check your answer.
Welcome.
The journey went well?
Quite.
It can be long.
It seems short.
I see you come bearing a gift.
It's customary for an official visit.
Okay, hopefully you were able To easily determine that angles 3 and 4 were complementary, you might have had trouble coming up with reasoning behind it. But you have a linear pair of congruent angles, so your lines are perpendicular. And then you have the sides of adjacent acute angles perpendicular, the angles are complementary. We're just going to finish this day with 2 more theorems. If a transversal is perpendicular to one of 2 parallel lines, it's perpendicular to the other. And if 2 lines are perpendicular to the same line, they are parallel to each other. So we're going to determine which lines are parallel, if any of them, and explain our reasoning. So first off, I have a line that's perpendicular to 2 lines. So those 2 lines are parallel. So there's our first. P is parallel to Q because you have S perpendicular to P and you have S perpendicular to Q. So there's one. And then you have the same scenario with Q. So you have Q perpendicular to S and Q perpendicular to T. So that's S parallel to T. So you go ahead and try the guided practice, the next 2 questions. Determine if B is parallel to A and explain why, and then determine if B is perpendicular to C and explain. Pause the video and then try on your own.
Here, Dolly. Silk-free filth.
Where are we expected?
There is something I wish to show you. Such a fine swoop. May I? This is an orthodox play.
Okay, in explaining the second one, you have A perpendicular to C and A perpendicular to D. So that makes C and D parallel. And since B is perpendicular to D, if it's perpendicular to one of 2 parallel lines, it's perpendicular to the other. So the answer to number 4 is yes, and that would be your reasoning. This ends day 1.